Hi everyone, this is the setup video for the Ohm's Law lab. Now this lab is a bit longer than the others, so it's going to be worth twice as many points, so the 48 points instead of the normal 24 points. Okay, so these setup videos are not a substitute for reading the actual instructions. You're going to have to go through that. I'm not going to go through everything here. The point of these setup videos is to help you to actually set up the equipment if you're having trouble following the pictures and everything. So I want to show you the things that are a little bit trickier to do with the actual setting up and connecting everything. Okay, so the first thing I want to do is you should have kept your setup from the previous lab. But I just want to change a little things here, a few things around just how we wire it, because we noticed that people were getting some numbers that were not consistent. So if you did the first lab, you calculated that there should have been about 0.3 millivolts or milliamps of current going through the 1 ohm resistor that you were using as an ammeter. So that's what you calculated, but a lot of you ended up with like 1.07 or something. And it turned out that that was because of the internal resistance of the breadboard. So what I want to do here is I'm going to show you a way to get rid of that internal resistance so you do get more accurate measurements. Okay, so this was our setup here. We had the 10,000 ohm resistor and the 1 ohm resistor connected in series there. And so what we're going to do to run the power to it is, instead of connecting two of these jumper wires with alligator clips together, we're just going to use them as they are. Okay, so for the power, we were using the 3.3 volt port, one of those ports. So I'm just going to plug the pin into one of those ports, and I'm going to connect that wire directly to this end of the 10,000 ohm resistor. So I'm going to clip it right on there, okay? And then that makes things a little bit neater too. You don't have as many wires running around. Okay, and then we need to ground our circuit so we have a full loop. So we'll plug another wire into ground. And then I'll connect that to the end of the 1 ohm resistor, okay? So then we have a complete circuit, okay? So I have the 3.3 volt connected to this end of the 10,000 ohm resistor and the ground to this end, okay? So that's how we get our power. Now, for our hard gain, we could do something similar for the G plus port. Okay, I'll just connect that to the positive side of the 1 ohm resistor. Okay, and then the G minus I'll connect to the negative end. Remember, the only reason that I'm calling these positive and negative are because, remember that we consider the 3.3 volt port to be positive, right? So the positive is on this end of the circuit, and we consider the ground to be negative, so on this end. Okay, so I have G plus here, G minus here. If you had it backwards, you'd just get a negative number, okay? So that's going to be essentially our new setup there, okay? And for this lab, what you're going to do here in part 1, you're also going to have to use a new feature of the software that you haven't used before. So we'll go ahead and turn it on, and there I am connected. And over here in the settings, the little cogwheel settings, there's an expert mode, and you want to click on output configuration. Okay, and what that will do is on the bottom left here, you'll have some output options. And we're going to use this DAC output, okay? And see, right now it's clicked to off, but we can click it to on. and you'll see that it turns right to 1.8 volts automatically. So we're going to switch that to 0. Okay. And then this part, you're going to, there's a lot of instructions here, but so I'm not going to go through all that, but you'll read in the instructions, you're going to use a high gain sensor, and you're going to be able to regulate how much voltage is going through the resistor through your circuit. So before it was just a 3.3 volts because it was in the 3.3 volt port. Okay. But now we can take it out of 3.3 volt, and then there's a port here right underneath the G plus that says DAC. Okay, we'll plug it into there, and that will allow us to control exactly how much voltage goes through the circuit. Okay, so if I record, all right, 0 volts going in, we'll see it should be close to 0. Okay, for me, it's about 0.024. So the reason for that, let's see here, are we on? Well, let's try that again. Okay, so we're running 0 volts through it, but you see we're getting, okay, I'm getting 0.025 millivolts. Okay, what that is just another way to measure our offset voltage like we did in the previous lab. Okay, so by putting 0 volts through, we can actually see what the actual offset voltage is. So hopefully it's similar to what your offset voltage was previously. Okay, and so you're going to go through this process where you're going to go through 0.5 volts at a time, record. So now I went from 0 to 0.5 volts. You see that I have a little bit more voltage there. And so if I click over that, you see it's 0.075 millivolts or milliamps of current. Okay, but there's an offset voltage of 0.025, right? So then you're going to have to subtract that 0.025. So it's really 0.05 milliamps is what's going through when I do 0.5 volts applied. Okay, so just be careful with that. And if it's underneath and it's negative, then you'll have to add whatever that is. So if this were negative 0.025, then you would have to add that to everything. Okay, so right, so this is your 0, but our 0 is not reading 0; it's reading 0.025. Okay, so that's our reference number. Okay. Okay, and then in part 2, you're going to do another series circuit here. Actually, before you go to part 2, you're going to actually take out your 10,000 ohm resistor and put in a 4.7 kilo ohm resistor. Okay, and that's in the bag marked with J0472 at the end. And you'll see that this resistor, it's got a little bit different. It has like a purple stripe, a red stripe, a yellow stripe. So it's a little bit different coloring scheme to identify it. And so you'll place that. So you're going to follow the instructions, but basically you're just going to put that in place of where the 10,000 ohm was. Okay. Then in part 2, when we're going to do some series circuits, you'll actually put the 10,000 ohm and the 4,700 ohm in series. So what I'll do here is I'll just start with my 10,000 ohm, and I'm going to move the one end because we need to get 3 of them in series here. So I'm going to kind of squeeze them together a little bit more. So that's my 10,000 ohm, and to put the 4,700 ohm in series with it, okay, I'll connect one end of the 4,700 in the same port as this end of the 10,000 ohm. Okay, so now they're in series. And then in order to measure current going through there, we're going to need that 1 ohm resistor again in series. Okay, so that's connected. So we have the 10,000 ohm connected to the 4,700 ohm, connected to the 1 ohm. Okay, and then we got our power going into one end, and then we'll have our ground going into the opposite end, so we can form our circuit. So we got a nice loop so that the current flows through the 10,000, then through the 4,700, then through the 1, and back to ground. Okay, and you'll follow the instructions for this to find see how resistance works in the series circuit. Okay, and then you want to see how voltage works in the series circuit. So for that part, we don't need the 1 ohm resistor, so we can take him out. And then we just have the 10,000 ohm in series with 4,700 ohm. And then for this, to measure voltage, we're going to go back to our analog 7 sensor. So we can get rid of our, take our G plus G minus is out. And then remember our analog 7 port. Okay. And then we're not going to use the DAC anymore. So we'll go ahead and move that wire back to the 3.3 volt port. Okay, so we got one end connected to the 3.3 volts. Okay, that end's connected to the 10,000 ohm resistor, which is connected to the 4,700 ohm resistor, and the end of that resistor is connected to the ground. Okay, now remember the way that we use the analog 7 sensor is it measures from whatever you connect it to the ground. Okay, so if I wanted to measure the 4,700 ohm resistor, I'll connect it to this side. So analog 7 measures between here and ground, which is already here. Okay, so that will enable us to get a measurement of voltage across that resistor. Okay, now the only way to measure this, if you think about it and try to play around with it, we can't just move the analog 7 here, right, and ground here, right? Because then we're just measuring voltage going through just this resistor. So if we want to measure going, what's the voltage through this resistor when it's in series with another resistor, okay, we're going to have to kind of flip things here. So what I mean is we'll swap places with the 10,000 ohm and the 4,700 ohm, okay? So we'll move 10,000 ohm to basically where the 4,700 ohm was. And if your resistors get a little hard to deal with, you can go ahead and I think there's a whole bunch in your kit. So after using them for a while, they sort of get hard to place. They start bending around and it's a little hard to work with. Okay. All right, so now I have a series circuit here. So now I have, they're still both in series, but the 4,700 ohm is first, and then 10,000 ohm is in second. Okay, so it's the same circuit, we just reverse which order they're in. So now I'll connect the 3.3 volt port to that end of the 4,700 ohm resistor, and I'll connect the ground to this end of the 10,000 ohm resistor. And then I can use my A7, plug that into, connect that to that that end of the 10,000 ohm resistor. Okay, and then that will enable us to measure with the analog 7 sensor what's the voltage going through 10,000 ohm resistor when it's in series with the 4,700 ohm resistor. Okay, and then in the last part, we'll do parallel circuits, and so what we'll do is we'll put these two in parallel. Okay, so what that means is that they're both connected, okay, where one end isn't that one ends are in the same row and the other ends are in the same row. Okay, that's parallel. Okay, and then to connect the power, we'll connect a 3.3 volt port, okay, I'll just connect it to the 4,700 ohm resistor, and then the ground to the other end of the 4,700 ohm resistor. Okay, because now with the setup like it is here, right, the current will come in through to this whole row here. So it'll go in through the 4,700 ohm resistor and simultaneously go through the 10,000 ohm resistor, and then go back around forming a circuit. Okay, and then to measure voltage, we can do, if we want to measure it over the 10,000 ohm resistor, we'll plug the analog 7 sensor on one end, and then we'll get another wire, and around that wire, plug it in one of the ground ports, and then connect that to the other end of the 10,000 ohm resistor. Okay, so we can use our analog 7 sensor to measure voltage through that. Okay, and unlike in series circuits, we don't have to swap them around. Okay, we can just move our analog 7 and ground over to the 4,700 ohm resistor and measure the voltage through that one. So then finally, we want to measure the current going through the parallel circuit, see how that works in parallel. Okay, so we'll have to insert one of our 1 ohm resistors in so that we can use that to measure current. So what I'll do is I'll put one end of that resistor in the same row as the 10,000 4,700 ohm resistor, and then I can plug it in anywhere else down here. Okay, so now it's like the 10,000 and 4,700 ohm resistors are in series or in parallel with each other, but they're both in series with the 1 ohm resistor. Okay, so I'll put my power, my 3.3 volts, onto this end, the 4,700 ohm resistor, and I'll put my ground right on this end of the 1 ohm resistor. Okay, and then we're going to have to stop using analog 7 sensor. We're going to have to use the G plus, G minus, the high gain sensor, in order to measure current, like we've done a bunch of times now. So I'll plug the G plus into this side of the 1 ohm resistor, and I'll take my other jumper wire, plug that into G minus, and then plug that into this end of the 1 ohm resistor. Okay, and that will enable us to see what's the current going through the entire circuit. Okay, and then finally we'll want to see what's the current going through each individual resistor. So to do that, we're going to have to get a second 1 ohm resistor. Okay, and we'll have a second 1 ohm resistor. And what we'll have to do here is we'll have to move, all right, we'll have to have 2 separate pathways. So we'll have one pathway where both the 10,000 ohm and the 4,700 ohm, they start in the same row, okay? And they're each gonna have a 1 ohm resistor connected in series with them, but they're gonna end in a different row. Or they're gonna end in the same row, but they're not gonna, the 4,700 ohm and the 10,000 ohm are not gonna end in the same row, okay? I'm gonna keep those rows separate. So 10,000 ohm over here ends in this row. So that for me, it's row 5, okay? So the 10,000 ohm goes from row 1 to row 5. And then the 1 ohm goes from row 5 to row 12. Okay. So now the 4,700 ohm starts in row 1, but I don't want it to be in row 5. So I'm going to put it in row 7. Then I'll connect the other 1 ohm resistor from row 7 to row 12, where the other 1 ohm resistor is. So we have basically 2 series circuits, right? The 10,000 ohm and the 1 ohm. And then I have another series circuit, the 4,700 and the 1 ohm. But since both of those circuits start in the same row and end in the same row, those are 2 parallel circuits. Okay, and then I'll hook my ground up. Okay, that way power is going in through both circuits and going back out to the ground. And then we can use the high gain sensor to measure current across each circuit. Okay, and so then that's it for the setup for the Ohm's Law lab.